Hi guys, so for today's discussion, what we're going to do is to solve some problems from topics that are included in our midterm exam. So let us start with our first problem here. We want to factor completely the expression 8s squared minus 14s plus 5. So for this expression, what we're going to do is to use factoring by grouping. So we start from the expression 8s squared minus 14s plus 5. So in order to use the method factoring by grouping, first we will decompose this minus 14s into the following expression. So we write 8s squared, and then for the 14s, particularly the minus 14s, we write it as minus 4s minus 10s. And then lastly, the constant term there, we have the plus 5. So in this current form, what we're going to do is to group this 8s squared minus 4s and then this minus 10s plus 5. So in the first grouping here, we see that 4s is actually a common factor. Okay? So if we factor out 4s in that group, what will remain inside is the expression 2s minus 1. Okay? And in this group, notice that 5 is a common factor. So what we're gonna do here is to factor out negative 5, okay? And from this group, we factor out negative 5, and what will remain inside is the factor 2s minus 1. So now observe that 2s minus 1 is a common factor of these two addends. Okay? And therefore, we can factor this expression 2s minus 1. So we factor that expression 2s minus 1. And what will remain inside is the expression 4s minus 5. 4s minus 5. So this is the final factored form of the expression 8s squared minus 14s plus 5. Okay? Next, for this problem, we want to factor completely the expression 16x to the 4 minus 1. So first, observe that 16x to the 4 minus 1 can be written as 4x squared, quantity squared, minus 1 squared. So looking at this form, we should easily see that the identity we're going to use in order to factor this completely is the identity difference of two squares. So we have a squared minus b squared. This can be factored into a minus b times a plus b. So following this identity, this expression now can be written as 4x squared minus 1 times 4x squared plus 1. Now, observe that this guy here is again of the form a squared minus b squared. So, see that this 4x squared here can be rewritten as quantity 2x squared minus 1. Again, let us just put squared there. And then for this guy, let's just write it as is because it is no longer factorable. So for this guy here, using this expression again or this identity again, this now can be factored into 2x minus 1 times 2x plus 1. And then we copy this 4x squared plus 1. And so, the complete factored form of 16x to the 4 minus 1 is 2x minus 1, 2x plus 1, 4x squared plus 1. For the next problem, here we want to factor completely the expression 4 times x plus 2 squared plus 20x plus 2 plus 25. So this expression is a quadratic in form expression. Okay? Meaning, if we only let y be equal to x plus 2, then this expression here can be seen as 4y squared plus 20y plus 25. And this is a quadratic expression. So the original expression is called quadratic in form because it can be transformed into a quadratic expression. So if you are not used to working on this kind of expression, the expressions quadratic in form, then you can do some substitution. So the expression would be simplified, at least the way you look at it. And then later, once you have already factored the expression, okay, you bring back the original variable and check whether things can still be factored or expressions can still be factored. If not, then that will be the complete factored form. Okay? So, let us try to factor this expression. So, remember the method if we have something like ax squared plus bx plus c. In order to factor this, we want to find a and b, small a and small b, such that the product AB, this is the product capital A, capital C, and that if you add A plus B, you will get capital B. So we want to find A and B, particularly integers, A and B, such that the product AB is equal to product capital AC, and then the sum A plus B, it's equal to capital B. So for this example here, our A, this is equal to 4. Our B, this is equal to 20. And our C, this is equal to 25. And if we multiply AC, this is equal to 100. So, we want to find small a, small b, okay, such that the product AB, okay, small a, small b, this is equal to 100. That's your AC here, okay? And then, if you add a plus b, you will get 20, which is the capital B. So on this column here, it's all throughout 100. And then in here, for A and B, try to find two factors of 100 such that when you multiply them, it's equal to 100. Okay? let us try to find some pairs. Maybe we can use 2 and 50. But notice, if you added 2 and 50, or if you multiplied, if you multiply 2 and 50, you will get 100. But if you added 2 and 50, you will get 52. So this is not the desired pair. You can also use 5 and 20. Okay? And if you added this, you will get 25. Okay? And then maybe you can think of 10 and 10. And in here, you multiply 10 and 10, you get 100. And if you added 10 plus 10, you will get 20. And this is our capital B. Okay? So this is the desired pair that we're going to use. And then in this method, what's next? What we do is to decompose the bx, the term bx, into this small ax plus small bx. Okay? So if we do that here, we will get 4y squared plus 10y plus 10y plus 25. And here, when you have this step, we do now factoring by grouping, or we use factoring by grouping. So in the first group here, we can factor out 2y, okay? Because both of these addends here, or terms here, are divisible by 2y. So we can factor out 2y, and what's left inside is the expression 2y plus 5. And then in this group, we can factor out 5 because 10 and 25 are both divisible by 5. So we can factor out 5, and what's left inside is 2y plus 5. And notice 2y plus 5, 2y plus 5 here, it's a common factor. You have this, you have this. So if you factor that out, again, you will have 2y plus 5, but the other factor will be 2y plus 5 as well. So in fact, this expression here is actually a perfect square trinomial. Okay? So if we rewrite that, or if we rewrite this, we can write this as 2y plus 5 quantity squared. Now, if we bring back the variable x, we will get 2 times y, which is x plus 2 here. So x plus 2 plus 5 quantity squared, and if we simplify this, we will get 2x plus 4 plus 5 quantity squared, and finally, we will get 2x plus 9 quantity squared. And this expression here cannot be factored anymore. So this guy here, 4 times x plus 2 squared plus 20 times x plus 2 plus 25 can be factored into 2x plus 9 quantity squared. Okay? For our next problem, we want to factor completely for x cubed minus 20x squared minus x plus 5. So we have a cubic expression here, and in our course, we had several factoring methods for cubic expression. One is if we have a plus b to the power 3. Okay? So if we expanded this, we will get a cubed plus 3a squared b plus 3ab squared plus b cubed. And of course, if we have the minus a minus b cubed, this is equal to a cubed minus 3a squared b plus 3ab squared minus b cubed. And also, if we have something like a cube minus b cube, the difference of two cubes, this guy here can be factored into a minus b times a squared plus ab plus b squared. Or if we have the sum of two cubes, a cube plus b cube, this is factored into a plus b times a squared minus ab plus b squared. Okay? And also, if there are no constant, for example, if the expression does not have the constant term, therefore you only see 4x cubed minus 20x squared minus 5, okay, assuming that this has no constant, okay, this has no constant. If you only see this, then observe x is a common factor, and therefore you can factor that out easily. And when you factor that out in this expression or from this expression, you will get a quadratic expression. And we had several ways, just like in the previous examples. Okay? But here, we have this constant here. So we have to observe which expressions are compatible with these identities. Okay? Now, if you try to get that one, in fact, this expression is neither compatible to any of the four identities here. So, there should be a way, which was discussed in this class, to factor this expression. And that one is, again, by means of grouping. So, we will factor this expression by grouping. Okay? So, if we group this and we group this, for this group, notice that 4 is a common factor and x squared is also a common factor. So, we can factor out 4x squared, and what's left inside would be x minus 5. While for this group here, what we will do is to factor out negative 1. So we factor out that negative, and what remains inside will be x minus 5. Now we clearly see that x minus 5 here is a common factor. And therefore, if we factor out x minus 5, okay, then we will have 4x squared minus 1 times that x minus 5. And again, 4x squared minus 1, we use difference of two squares because 4x squared can be written as 2x quantity squared and then minus 1. Let me just put that squared again. And then here you have x minus 5. So for this expression, we use again difference of two squares. We have 2x minus 1 times 2x plus 1 times x minus 5. So this is the complete factored form of this expression here. Okay? So therefore, if we see cubic expression, we can factor it by grouping, okay? Or if there is no constant term, you can factor out x, okay? Or if you try to observe the coefficients, particularly, they will follow some sort of these formulas here, okay? For the next problem, we want to perform the indicated operations 3y over y squared plus y minus 12 minus y over y squared minus 16. So, of course, first, what we're going to do is to combine this expression into a single fraction. Okay? So, we have the difference of two rational expressions here. We will combine them into a single rational expression. And one way to do that is to study the denominators and find the LCD. And then we will rewrite each rational expression using LCD as the denominator. So first, let us factor the denominators. So your y squared plus y minus 12, okay? Practice on factoring. You should be able to factor this into y plus 4 times y minus 3. And then for this guy here, we have difference of two squares, y squared minus 16. This is equal to y minus 4 times y plus 4. And observe that the LCD, okay, it is composed of the products of the factors that we see, and each factor is raised to the highest power that we see for that particular factor. So the factors that we see here are y plus 4, and then we have y minus 3, and then we have y minus 4. And then here, there's y plus 4, but we already have written it. Now, the highest power of y plus 4 is 1, because here, y plus 4 has power 1, y plus 4 has power 1. So, we just have y plus 4 power 1. Similarly, for y plus 3, or y minus 3, the highest power is 1, because here we have y minus 3 to the power 1, but here doesn't have any y minus 3. And also, for y minus 4, the highest power is also 1. Same explanation as in y minus 3. Therefore, if we compute the difference of these two expressions, okay, we write the rational expression using the LCD here. So y plus 4, y minus 3, y minus 4. Okay? And again, this y plus 12, or y squared plus y minus 12 is factored into this. Okay? So from here, we have the factor y plus 4 and y minus 3, but we don't have the y minus 4, and we want to put it on the denominator. We must also put it in the numerator. So you have your y minus 4 here, and of course, don't forget that 3y. And then minus, again, we write the LCD in the denominator, y plus 4, y minus 3, y minus 4, and y squared minus 16, okay? Y squared minus 16 here, it's factored as its factored form is y minus 4, y plus 4. We have the y plus 4 here. We have the y minus 3 here. We put y minus 3. Sorry, we have the y plus 4 here, y minus 4 here. And then we put y minus 3 on the denominator, which is missing here. So we have to put the y minus 3 also in the numerator. And don't forget the y there. And now, they have the same denominator. We can now combine them into a single numerator. And we will have 3y times y minus 4. We have the minus here. So we have minus y times y minus 3. And then single denominator. So you have y plus 4 times y minus 3 times y minus 4. And then we factor. We factor and we simplify. But notice in the numerator, you have a y here and you also have a y here. It's a common factor of this term here and of this term here. So, we can factor out y. Okay, we can factor out y. We will have y times the quantity. And what remains for each, okay, for each term? We have here 3, y minus 4, and then minus, we have y minus 3. And then close parenthesis. And then again, we just copy the denominator. You have y plus 4, y minus 3, y minus 4. And we just simplify this expression here and see if we can simplify further. So y times here, you have 3y minus 12. And then here, distribute the negative properly. So you have minus y plus 3. And then denominator again, you have y plus 4, y minus 3, y minus 4. And further simplification will give us y times 3y minus y, that's 2y, minus 12 plus 3, that's minus 9, divided by y plus 4, y minus 3, y minus 4. And there is nothing to cancel here. Therefore, this is our final expression. For our next example, we want to perform the indicated operations 6 plus 2 over x all over 3x plus 1 divided by 4. So here, what we're going to do, in the numerator, we combine it to a single rational expression. That's what we're gonna do first. So this guy here can be written as 6x over x plus 2 over x. And then the big denominator here, it's just 3x plus 1 over 4. Then we combine this. It becomes 6x plus 2. Okay? It becomes 6x plus 2 divided by x all over 3x plus 1 divided by 4. And then, from division, we rewrite this as multiplication. And doing that, it means that here, the big denominator we will have to get its reciprocal. So we will have 6x plus 2 divided by x times you have 4 over 3x plus 1. And now in here, we easily see we can factor out 2. Okay? In this 6x plus 2. So factoring 2, we will have 2 times 3x plus 1 over x, and then times 4 over 3x plus 1. And notice, 3x plus 1 here, 3x plus 1 here, they can be cancelled, which therefore gives us 2 times 4, that's 8, and the denominator, it's simply x times 1, so it's just x. So this is the final expression of this complex rational expression. Next problem. Again, we want to perform the indicated operations. So we have this 2x squared minus 6x over x squared minus 1 divided by x squared minus 2x minus 3 all over x minus 1 quantity squared. So first, what we're going to do is to rewrite this as a multiplication. Okay? So let me rewrite the original expression, 2x squared minus 6x divided by x squared minus 1, everything divided by x squared minus 2x minus 3 over x minus 1 quantity squared. So first step, we rewrite it as a multiplication. So we have 2x squared minus 6x divided by x squared minus 1 times, so multiplication, we have to get the reciprocal of this. We have x minus 1 quantity squared divided by x squared minus 2x minus 3. Then, we factor everything that we can factor. And we will see if we can cancel some expressions. So here, we factor 2x. So we have 2x times, what remains is the expression x minus 3. For the denominator here, we factor that into x minus 1, x plus 1 times. Of course, x minus 1 squared, it's completely factored. For the denominator here, this can be factored into x minus 3 times x plus 1. And here, we see that we can cancel x minus 3. Okay? We see that we can cancel x minus 3 here and x minus 3 here. We also see that we can cancel the x minus 1 here and one of the x minus 1s in here. So we still have power 1 here. Okay? And therefore, this can now be written as 2x times x minus 1 divided by, okay, so 2x, the x minus 1 is still here, that's power 1, so let's just write it as x minus 1. And then here you have x minus 1 times x minus 1. So let us write that as here we have x plus 1 times x plus 1. Okay, x plus 1 times x plus 1, so we rewrite it as x plus 1 quantity squared. So there's nothing to cancel anymore, and therefore this is the final expression. So for this problem, we want to perform again the indicated operations. So you have 2m plus 3, m minus 4 over m squared plus m minus 20 divided by 4m squared minus 9 over m squared plus 4m minus 5. So again, we use the same method as in the previous slide. So we copy this first, okay? And then we change this to multiplication. And then we factor these three expressions. This is already in factored form. Here, we factor this, we factor this, we factor this. So factoring is really essential, okay? So we copy. We have 2m plus 3 times m minus 4 over m squared plus m minus 20 divided by 4m squared minus 9 over m squared plus 4m minus 5 equals. And then we change this to multiplication. So here in the numerator, you have 2m plus 3 times m minus 4. Okay? Now, I know that I'll be changing this to multiplication. So that's what I am already thinking. So at the same time, what I'm going to do is to factor this m squared plus m minus 20. Because it is already in my mind that I'm gonna change this to multiplication. So if we factor m squared plus m minus 20, again, practice your factoring. But this expression here can be factored into m plus 5 times m minus 4. Okay? And then times. So we get the reciprocal. We get the reciprocal. So in the numerator here, it's this m squared plus 4m minus 5. And again, I'm going to factor that now. Okay? And the factor will be m plus 5 times m minus 1. Okay? And then this guy here, 4m squared minus 9, will be going to the denominator. And this is a difference of 2 squares, so we'll factor this again into 2m minus 3, 2m plus 3. So now, everything is in factored form, and this is multiplication. We can start canceling terms. For m minus 4, we'll cancel this. We can easily see that they are, one is on top of the other. Here, 2m plus 3, there's a 2m plus 3 here. So 2m plus 3 in the numerator, and there's a 2m plus 3 on the denominator. So this guy here will cancel this guy there. And then we have an m plus 5 in the numerator here, and there's an m plus 5 in the denominator here. So we cancel m plus 5 here with this m plus 5 here. So what remains are the factors m minus 1, it's in the numerator, and then 2m minus 3, which is in the denominator. So the final expression will be m minus 1 over 2m minus 3. So this is the final expression. Now, for the next problem, simplify expressing the final result with positive exponents only. Okay? So in this expression, we see some positive and negative exponents. we have fractional exponent here, and we have radical. Okay? If we have a radical, and there are other exponents, or there are other expressions which have exponents, convert the radical to exponents. So let me recall that one. You have nth root to the a. This is equal to a raised to 1 over n. And of course, if n equals 2, you just have the square root of a. Okay? And this is equal to a raised to 1 half. So this is particularly helpful in this expression here, the square root of. And then this expression here, enclosed in parentheses, raised to negative 2. So we will apply laws of exponents. Particularly, we will multiply this exponent negative 2 here outside the parentheses to each of the exponent inside the parentheses. Okay, because they are all multiplied to each other. So recall that law of exponent. So anyway, inside the parentheses, let us rewrite these guys here. Okay, you will have 2 to the 3, a raised to negative 2, b raised to 1 half, over 2 raised to negative 2, a to the 4, b raised to negative 5 halves. And then everything raised to negative 2. So notice what only changed here is the expression square root of b. We change it to b raised to 1 half. And then next, we work inside the parentheses. We combine like base. Okay, we check the exponents of the same base. For example, here you have base 2 here, you have base 2 here. So we check the exponents. Okay, and then we use law of exponents. So in here, in the numerator, you have 2 cubed. In the denominator, you have 2 raised to negative 2. Okay, so check the exponent. Check which exponent is lower, and then change that power, okay, or put that expression with the lower exponent to the other side of the bar or of this middle line here. Okay, so what I'm saying is, for example, in the base 2 here, 2 cubed and then 2 raised to negative 2, 3 is bigger than negative 2, or negative 2 here, it's smaller than 3. So we move 2 raised to negative 2 from the denominator to the numerator. And of course, when you move, you replace now the sign of the exponent, or you change the sign of the exponent. So here we will have 2 to the 3. If we put this in the numerator, the minus 2 becomes positive 2, and that, therefore, you will add that to the exponent here. Okay? If this is too fast, let us write it this way. So 2 to the positive 2. So we brought 2 raised to negative 2 from the denominator going to the numerator, and we change the exponent. Next, for the a. In the numerator, you have a raised to negative 2. In the denominator, you have a raised to positive 4. Negative 2 is smaller than positive 4. So we bring a raised to negative 2 from the numerator going to the denominator. And then we change the sign of negative 2. So we will have a to the 4 here. So this a to the 4 here will remain. in the denominator, and then this guy here will go to the denominator as a raised to positive 2. And then for the base b here, okay, for the base b here, you have b raised to positive 1/2, b raised to positive 1/2 in the numerator. And then in the denominator, you have b raised to negative 5/2. So 1/2 is greater than negative 5/2. Okay? 1/2 is greater than negative 5/2, or negative 5/2 is smaller than positive 1/2. So we bring b raised to negative 5/2 from the denominator to the numerator. So the numerator, we will have b raised to 1/2, and then this guy here, we bring it up. It becomes b raised to positive 5/2. And then in here, we still have raised to negative 2. Okay? So from here, we now apply one particular law of exponent. So 2 to the 3 times 2 to the 2. What we do is to combine or to add the exponents. So here we will have 2 to the 3 plus 2. So 3 plus 2. I'll do this step by step. And then in here, we will have b raised to 1/2 times b raised to 5/2. It becomes b raised to 1/2 plus 5/2. And then on the denominator, you have a raised to 4 times a raised to 2. So it becomes a raised to 4 plus 2. And again, multiplied, or again, raised to negative 2. Then we add the exponents now. You have 2 to the 5. Okay, 2 to the 5. And then 1/2 plus 5/2. So 1/2 plus 5/2, that's 6/2. So 6 over 2, that becomes 3. 6 over 2, it's 3. And then on the denominator, you have 4 plus 2 as an exponent of a. So this becomes a to the 6. And then inside the parentheses, so we put it inside the parentheses, we still have exponent negative 2 here. Okay? And then we distribute this exponent negative 2 to each of the factor here, because these are multiplications. So you can do that. You just multiply the exponent, okay, of the expression inside with the exponent here outside the parentheses. Meaning, we now have here 2 raised to 5 times negative 2, that's negative 10. And then b raised to 3 times negative 2, that's negative 6. And then on the denominator, you have a raised to 6. And 6 times negative 2 here, it's now a raised to negative 12. And then we want positive exponents only. So we change all the negative exponents into positive by moving the expression to the other side of the bar here. And therefore, your final expression should be a raised to 12 divided by 2 to the 10 b to the 6. And then you can find the exact value of 2 to the 10, or you can leave the final answer as it is. So this is the final expression for this guy here. Okay? Next problem here. Simplify expressing the final result with positive exponents only. So similar as in before, but you have to look at the denominator. Okay? So some students would do the same solution as I'm going to present. So in here, I have negative exponent here, and I also have negative exponent here. So I'll interchange them. I'll put this guy here in the numerator, and then I'll put this guy here in the numerator. Okay? Some students do that. So let us try to do that. Okay? So let me copy the problem first. Here we have negative 4 x raised to negative 3 y squared z raised to negative 1 quantity raised to negative 2 divided by quantity and another quantity 2x raised to 3 y raised to negative 2 z squared and then raised to negative 3. Then I'll follow the solution of some students. So negative exponent here at the very outside, negative exponent here at the very outside. So bringing them up or down respectively. So in the numerator now, you will have quantity 2x raised to 3, y raised to negative 2, z raised to 2, and then close quantity here raised to positive 3. While in the denominator, we'll get negative 4 x raised to negative 3 y squared z raised to negative 1 and then close quantity there raised to positive 2. Then this 2x, it's raised to cube. So let's distribute first the exponent 3 here to each of 2 and 8 and x, I mean. Okay? So for that, you will get 2 cube x cube. And then you have your y raised to negative 2 z squared and then close quantity to the power 3 divided by, here you have negative 4. Okay? Sorry, I think I wrote the problem here. There's a negative outside here. Okay, let me adjust that one. Let me adjust that one. So I have the negative here. So I will have the negative in here. And therefore, in here, I will have negative quantity here. Okay, so let us continue. Here in the denominator, I have x raised to negative 3, y squared, z raised to negative 1, raised to power 2. So the only difference is that I distributed this power 3 to this, the one inside this. Okay? Common mistake of the student, okay, is that they don't distribute the exponent 3 to the constant. You have to do that because this constant is just another letter with an actual value. Okay? Then, loss of exponent here. Okay? So in here, in the numerator, so distribute this power 3 from the outside the bigger parenthesis to each of the term. So I will get negative 2 to the power 3 times 3, that's 9. Here you have x to the power 3 times 3, again that's 9. And then y to the power negative 2 times 3, that's negative 6. Here z to the power 2 times 3, that's 6. And then denominator, we will get negative 4 raised to power 2 raised to power 2 And then here, x raised to power negative 3 times 2. That becomes x raised to negative 6. Okay? And then you have y raised to power 2 raised to, sorry, y raised to power 2 times 2 there. So that becomes y raised to power 4. And in here, z raised to power negative 1 times 2. That becomes z raised to negative 2. Okay? And then you can work on the constants. Negative 2 raised to power 9. I think that's 512 negative. So negative 512. Please check. Please check this. Okay. I believe it's negative 512.
That's correct.
And then here, you have x to the 9 in the numerator, x to the negative 6 on the denominator. So negative 6 is smaller than positive 9. We bring this term here, x to the negative 6, up there. So we'll have x to the 9 and then x to the 6. Okay, x to the 9 times x to the 6. We have y raised to negative 6 in the numerator, y raised to negative 4, or y raised to positive 4 in the denominator. Negative 6 is smaller than positive 4. We bring this down. Okay? So here, let us also start writing something in the denominator. You have negative 4 squared. That's positive 16. And then for the y, we have here y to the 4. And then here we bring it down the denominator. So we will have y to the positive 6. And then here, z to the 6 in the numerator, z raised to negative 2 in the denominator. We bring this z raised to negative 2 from the denominator going to the numerator. So z to the 6, z squared. And then we apply laws of exponents, and then we simplify also. For the constant, you have negative 512 divided by 16. Do the division, it's negative 32. And then here you have x to the 9, x to the 6. You add the exponent. So x to the 15. Here, z to the 6, z to the 2. Add the exponent. You'll get z to the 8. And here you have y to the 4, y to the 6. Add the exponent. You have y to the 10. And again, this 16, it was used to divide this negative 512. So you don't put the 16 in here. So this is the final expression. So next problem, the same. You have x, or 8x raised to 3 halves, y raised to 5 halves, all over square root of 4xy. So again, you have here radicals. Okay, change it to fractional exponent because it's easier to work if you have all exponents than you have a combination of fractional exponents and radicals. And even if you have all radicals, sometimes it's easier to work with fractional exponents. So we convert the radicals to fractional exponents. And it's totally fine. So anyway, first, for this, we can distribute these 3 halves. In here, we can distribute this exponent 3 halves for 8 and then x, so that we will have 8 raised to 3 halves, x raised to 3 halves. And then you have your y raised to 5 halves. 5 halves. And then on the denominator, you have square root of 4xy. Okay? Let us do first square root of 4, square root of x, square root of y. So remember that law. Remember that law. Square root of AB, this is square root of A, square root of B. Which means from here, square root of 4, that's just 2. And then your square root of x, okay, we convert it to fractional exponent. Okay, so let us write the numerator now. It's 8 raised to 3 halves. And then you have x raised to 3 halves, y raised to 5 halves. And then denominator, you have 2. That's the square root of 4. And then x raised to 1 half, y raised to 1 half. Okay? Now, look at this. 8, your 8, it's 2 times 2 times 2. Correct? 8, it's 2 times 2 times 2. So, you will have 2 cubed raised to 3 halves. Okay, 2 cubed, that's your 8. 2 times 2 times 2, that's 8. 2 cubed. And then here you have x raised to 3 halves, x raised to 1 half. 1 half is smaller than 3 halves. So we bring x raised to 1 half up there. Okay? So from x raised to 3 halves in here, okay? X raised to 3 halves in here, you attach or you bring this x raised to 1 half from denominator to numerator, you will have x raised to negative 1 half. And then you have your y raised to 5 halves. So the exponent 5 halves here, exponent 1 half here. 1 half is smaller than 5 halves. So we bring y raised to 1 half from the denominator going to the numerator. That's why I have here y raised to 5 halves and then y raised to negative 1 half. And then you have your over 2. That's what's left. Then later, this 2 guy here, it will be brought up there. Okay? Let us simplify first the numerator. You have 2 to the 3 raised to 3 halves. So we multiply this exponent 3 to the exponent 3 halves. So you will have 2 to the power 9 halves. Okay? So let me rewrite this clearly. 9 halves. And then in here, you have x raised to 3 halves, x raised to negative 1 half. So 3 halves minus 1 half, it becomes x raised to 2 over 2. Okay? But 2 over 2 is just 1. But let me write 2 over 2. And then in here, you have y raised to 5 halves. And then y raised to negative 1 half. So 5 halves minus 1 half, that's 4 over 2. And then you have your over 2 in the denominator. Okay? So, again, in here, what happened? We brought this, if you bring an expression from denominator to the numerator, you change the sign. So if the sign is negative, it becomes positive after bringing it to the other side of the line. If the sign was positive, change it to negative after bringing the expression to the other side of the bar. Okay? So whatever the exponent is, Okay? Whatever the exponent is, once you bring the expression from denominator to numerator, or from numerator to the denominator, you change the sign of the exponent. And then let us continue here. You have 9 halves, exponent of 2 here, 9 halves. Here, you just see 2, but its exponent is actually 1. 2 to the 1, it's 2. Which means 1 as an exponent is less than the exponent 9 halves here. So we bring these 2 up there, which means you will get 2 raised to 9 halves minus, or let me write 2 raised to negative 1 here. And then x raised to 2 over 2, that's just x raised to 1. So I'll just put x. Then 4 over 2, that's 2. So I'll have y squared. And then finally, let's just solve 9 halves minus 1. That's 9 halves minus 2 over 2. And that's 9 halves minus 2 over 2. That's 7 halves. So 2 raised to 7 halves. And then you have your x. And then you have your y raised to 2. So this is the final expression for this expression here. Okay? So here, we want to rationalize the denominator and simplify. So what will work in here? We recall difference of two squares formula. So a squared minus b squared, this is your a plus b, a minus b. Or maybe you can have the a minus b. This is equal to square root of a plus square root of b times square root of a minus square root of b. Or the combinations of all of this. They mean the same thing. They mean the same thing. Okay? But what is the point? In this type of problem, you look at the denominator. You see sum or just the radical. So sum of numbers, one of them is a radical, or possibly both of them are radicals. Okay? Sum or difference of two numbers. So what you do is to multiply both numerator and denominator by what we call the conjugate. The conjugate, if it is a plus, the conjugate becomes a minus. So this is plus, this is a minus. If the original question was minus here, you multiply it with the plus. Okay? So you look at the denominator, if there is a radical there, sum or difference, you multiply both the numerator and denominator by the conjugate of the denominator. So meaning, here, in this particular expression, the denominator is 2 plus square root of 10. The conjugate is 2 minus square root of 10. So if you are going to multiply 2 minus square root of 10 in the denominator, you multiply also the numerator with the same expression. 2 minus square root of 10. Okay? And doing this means the denominator here, it becomes what? Applying this here, applying this identity to this. So you have 2 plus square root of 10 times 2 minus square root of 10. That becomes 2 squared minus quantity square root of 10 squared. That's this guy here. You have the a plus b multiplied to a minus b. You get a squared minus b squared. So here, 2 plus square root of 10 multiply to 2 minus the square root of 10, you have 2 squared minus quantity square root of 10 squared. That's for the denominator. For the numerator, you just apply FOIL method or the distributive method. Okay? So here, this expression multiplied to 2. Let us do this one by one. So 5 square root of 2 times 2, that's 10 square root of 2. Next, 5 square root of 2 times negative square root of 10. So multiply it here. That becomes what? Let us write it as, so minus 5 square root of 2 square root of 10. Okay? And then next, here you have 2 square root of 2, 2 square root of 2 multiplied to 2. So 2 square root of 5 multiplied to 2. Okay? So 2 square root of 5 times 2, that becomes plus 4 square root of 5. And then finally, 2 square root of 5 multiplied to negative square root of 10. Okay? So it's just the distributive property we are applying. So this becomes minus 2 square root of 5 square root of 10. Okay? Now, square root of 10, let me write it here. Square root of 10. Note that 10 is 2 times 5. So square root of 10, this is square root of 2 times 5, which means this is just square root of 2 square root of 5. Correct? So let us do that to the square root of 10s that we see in here. Okay? Therefore, in the numerator, we have the 10 square root of 2 minus 5 square root of 2. And then the square root of 10, we use this. You have square root of 2 square root of 5 plus, here we have 4 square root of 5. And then we have minus 2 square root of 5. And then again, you have the square root of 10 here. So square root of 2 square root of 5. And then in the denominator, we will have 2 squared, that's 4. And then square root of 10 squared, that's just 10. And then here, we will now have 10 square root of 2 minus 5. And then you have square root of 2 times square root of 2. That's just 2. Then we still have that square root of 5 there. Plus 4 square root of 5 minus 2. And then here you have square root of 5 times the square root of 5 here. So square root of 5 here times the square root of 5 here. That's 5. And we still have the square root of 2. And then denominator, 4 minus 10, that's minus 6. And then let us write this guy here. So it's 5 times 2, that's 10, square root of 5. And then in here, you have 2 times 5, that's 10, square root of 2. And then notice, you have 10 square root of 2 minus 10 square root of 2. They'll just cancel each other. So this guy here will cancel this guy here. Again, That's 10 square root of 2 minus 10 square root of 2. So they will be cancelled. While you have minus 10 square root of 5 plus 4 square root of 5. So minus 10 plus 4, that's minus 6 square root of 5 divided by minus 6, and this is just square root of 5. So this is the final expression. Next problem here. Again, rationalize the denominator. Square root of 5 over 2 plus square root of 3. So, we look at the conjugate. 2 plus square root of 3. The conjugate, this is a plus, so the conjugate will be the minus. Meaning, you divide or you multiply both the numerator and denominator by 2 minus square root of 3. That's on the denominator. You also do that in the numerator. Okay? And therefore, here, we distribute this 5, or this square root of 5. So this guy here, distribute there, and then distribute there. So the numerator, 2 times square root of 5. So 2 square root of 5 minus, because this is minus, square root of 5 square root of 3. Square root of 3. And then here, difference of two squares formula. Remember that? That becomes 2 squared minus square root of 3 squared. And in here, we just need to simplify 2 square root of 5 minus, you can multiply them, 2 square root of 5 times 2, square root of 5 times square root of 3, that's square root of 15. Okay? That's square root of 15. But I am allowing you to just write square root of 5 times square root of 3. If you multiply them, it's totally fine. And then in here, you have 4. That's your 2 squared. Then minus square root of 3 quantity squared, that's just 3. And 4 minus 3, that's just 1. So your final answer can be written as 2 square root of 5 minus square root of 5 square root of 3. Okay? Next problem here, rationalize the denominator and simplify. Square root of 12 over square root of 7 minus square root of 3. So we have the minus here on the denominator. So we multiply it with the plus there. So square root of 7 plus square root of 3. And then you do the same thing in the numerator here. Okay? So as in before, here we just distribute to each. So we will have square root of 12 times square root of 7 plus square root of 12 square root of 3. While on the denominator, you have square root of 7 quantity squared minus square root of 3 quantity squared. Now, let's see. 12, it's 4 times 3. So square root of 12, this is actually square root of 4 times 3. And this is square root of 4 times square root of 3. But square root of 4, that's just 2. So you have 2 square root of 3 there. Therefore, here, we can write it as 2 square root of 3, and then there's a square root of 7. And then here you have 2 square root of 3, and then there's another square root of 3 there. Divided by denominator, you just have 7 minus 3. If we simplify, square root of 3, square root of 7, that's if you multiply them, you cannot simplify that. You cannot turn it to rational. So you can multiply square root of 3 and square root of 7, or you can just write it as is. Of course, do not forget this 2 here. So we write it as is, 2 square root of 3 square root of 7. Whereas here you have 2, you have square root of 3 times the square root of 3. And that's 3. So you have something like this. Correct? And then denominator, 7 minus 3, that's just 4. So 4 divisible by 2, you have a 2 here, and you also have a 2 here. You can cancel the 2. Okay? Because all of the terms or all of the addends in the numerator has a factor 2. Okay? So, this simplifies to square root of 3, square root of 7, and then here plus 3 divided by 2. So, this will be the final expression. Next problem. We want to solve the equation x squared plus 8 x times x plus 8 equals 3. So we rewrite this. You will get, so you distribute the x. You have x squared plus 8x and then equals 3. And then we rewrite this in standard form. You have x squared plus 8x minus 3 equals 0. And then from here, you can use your quadratic formula. Let me write again here the quadratic formula. So it should be x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So here you have your x equals. This is your b. Of course, a is 1, b is 8, c is negative 3. So negative b, that's negative 8 plus or minus square root of b squared. So 8 squared minus 4 minus a minus c. Or minus 4 times a times c divided by 2 times a. So we simplify. We have negative 8 plus or minus square root of 8 squared, that's 64. Minus 4 times 1 times negative 3, that's plus 12. And then divided by 2. Okay? And then we move it here, equals. So x is equal to minus 8 plus or minus 64 plus 12, that's 76 all over 2. Now let us look at 76. 76. This is equal to 4 times 19. 4 times 19. Okay. And therefore, we have negative 8 plus or minus square root of 4 times 19 all over 2. But square root of 4, again, that's just 2. So minus 8 plus or minus 2 square root of 19 divided by 2. And therefore, we divide everything by 2, we'll just get minus 4 plus or minus square root of 19. And this is, or these are the solutions to this equation here. Next problem here. Solve the equation, and we have this. So we just distribute properly. Okay. See that this is just a linear equation, so distribute properly and solve for x. So here we distribute the negative, so you have minus 4x, and then minus times negative 2 here, that becomes plus 2, plus 2 times negative 3x, so you have negative 6x, okay? Then plus 2 times 5, that's 10. This is equal to 3. So from here, we see you have negative 4x and then minus 6x. So that becomes minus 10x. And then here we have a constant, we bring it to the other side. Okay? So you have here equals 3. Here, let's add 2 plus 10, that's 12. Then we bring it to the other side, which means you will get minus 12 here. So 2 plus 10, that's 12. You bring it to the other side, that becomes minus 12. And therefore, you will have minus 10x equals minus 9. So your x equals minus 9 over minus 10, or simply x equals 9 over 10. Next problem. We have here 4x cubed minus 8x squared minus 20x equals 0. So we have a cubic equation in here. But notice, 4x cubed minus 8x squared minus 20x, there is no constant here. In fact, the constant is 0. Okay? Which means, if we look at this expression, okay, we can easily factor out x. In fact, we can factor out 4x because you have 4, you have minus 8, and you have minus 20. So from this expression, or this equation, we now write 4x times. What remains inside here? We factor out 4, we factor out x, we have x squared. We factor out 4, we factor out x. What remains here? It's minus 2 minus 2x. And in here, we factor out 4, we factor out x. What remains here? It's minus 5. And then this is equal to 0. Let me recall the 0 property. Remember, if a, b, the product of a times b equal to 0 is equal to 0, then a equals 0 or b equals 0. Of course, you have 4 times x times this guy here. 4 will never be 0. So it's out of the question. Your x, it can be 0. So x equals 0, or this guy here, this expression here, x squared minus 2x minus 5 equals 0. Minus 2x. So x squared minus 2x minus 5 equals 0. So we just followed this 0 property here, 0 product property here. Of course, x equals 0, it's done. Our work now is for this quadratic equation here. Again, we can use quadratic formula. So this guy here, x, it's equal to negative b. So negative of negative 2 plus or minus square root of b squared. So negative 2 squared minus 4 times a times c. Okay? All over 2a, 2 times 1. And then we just simplify what we can simplify here. So here you have negative negative 2, that's positive 4, plus or minus negative 2 squared, that's positive 4. You have negative 4 times 1 times negative 5, that's positive 20, and then divided by 2. Or we can write this as 4 plus or minus square root of 24 divided by 2. And again, looking at 24, same as in before, your 24, it is 4 times 6. You can think of 24 as 12 times 2. You can think of 24 as 3 times 8. Totally fine. Why am I choosing this 4 times 6? Is because you can get square root of 4, which is 2. And then square root of 6, it's just as is. You cannot simplify that anymore. Okay? So you will have here 2 square root of 6. And therefore, in here, you will have 4 plus or minus 2 square root of 6 over 2, or this is just 2 plus or minus square root of 6, because you can cancel out the 2. Okay? All of the addends in the numerator have factor 2. 4, it's 2 times 2. Of course, 2 square root of 6, there's a 2 there. So this is the final expression. Okay, so that's a good spot. Negative, should be positive 2 here. Correct, correct. So you have here positive 2, positive 2. So this is 2. Then 2 here. And of course, this is still 2 here. And in that case, this is 1. Okay? Therefore, by the way, this is not the final answer. The final answer includes the 0. Okay? So we also box this. So 3 possible solutions are x equals 0, x equals 1 plus square root of 6, and x equals 1 minus square root of 6. Those 3 numbers will solve this equation. Next problem here, we have x minus 2 over x minus 5 equals 15 over x squared minus 5x. So for this, we use LCD method. So you have to get the LCD, okay? You have x minus 5 here. Here, if you factor, let me write the factor here. The factor of this guy, it's x times x minus 5. And therefore, the LCD, it's just x times x minus 5. So x times x minus 5. So we multiply both sides of the equation, okay, by this LCD. So let me write the problem here. X minus 2 over x minus 5. And then we multiply this by the LCD. The LCD, it's x times x minus 5. Then this is equal to 15 over x squared minus 5x. Again, multiply the LCD, x times x minus 5. So what you do on the left-hand side must be done on the right-hand side to retain the equality. But in here, on the left-hand side, we can cancel x minus 5. So what will remain is x minus 2 times x. And that we will get x squared minus 2x. On the other side, we can cancel everything in the denominator. X squared minus 5x, it's just x times x minus 5. Which means that this guy here will cancel this guy here. So on the other side, we just have 15. We rewrite this into standard form. So x squared minus 2x minus 15 equals 0. And therefore, try to check this is factorable. It's factorable into x minus 5 times x plus 3. This is equal to 0. Which means either x minus 5 equals 0 or x plus 3 equals 0. But notice, we have a denominator x minus 5, and we don't want the denominator to be 0. But in here, we got x minus 5 equals 0. So this guy here cannot happen. Cannot be. So the only solution is this. X equals negative 3. Okay? For the last problem, for this review, okay? We have 1 plus 3 over x minus 2 equals 12 over x plus 2 x minus 2. So again, we use LCD method, and we see denominator here, it's 1. Here, denominator x minus 2. Here, denominator is x plus 2 times x minus 2. So we can easily check that the LCD is actually x plus 2 times x minus 2. Okay? So we multiply both sides of the equation by the LCD, 1 plus 3 over x minus 2. Quantity, multiply the LCD, x plus 2, x minus 2. And then this is equal to 12 over x plus 2 times x minus 2. Then again, multiply the LCD, x plus 2x minus 2. So on the right-hand side, we can easily cancel this guy here. So the right-hand side will just get 12. On the left-hand side, we distribute this to this guy here and to this guy here. So for the first, you will have x plus 2 times x minus 2 plus 3. For this guy here, you have that 3, and the x minus 2 is cancelled. So you just multiply the 3 with the x plus 2. Then simplify x squared, or sorry, x plus 2 times x minus 2, that's x squared minus 4, plus distribute this, you will get 3x. Then here, 3 times 2, that's your 6. And then equals 12. And then we write this in standard form. We have x squared plus 3x. And then here you have minus 4 plus 6. So minus 4 plus 6, that's plus 2. And then this guy here, we bring it to the other side. So you have minus 10 equals 0. Or we have x squared plus 3x minus, sorry, it's minus 12 in here. Minus 12. And then 2 minus 12, that's minus 10 equals 0. And again, factoring. This can be factored. This expression here can be factored into x plus 5 times x minus 2 equals 0. Okay? So x plus 5 times x minus 2. And 0 product property. You have x plus 5 equals 0, or x minus 2 equals 0. But then again, denominator, we have x minus 2 and we have x plus 2. This guy here cannot happen because we don't want x minus 2 to be 0. So this guy here cannot be. Okay? And therefore, we only have this expression, x plus 5 equals 0, or x equals negative 5. So that's the end of the review session. So thank you for staying, and I hope you learned something. Thank you.